Welcome back. We're going to continue on here. We've been learning about acids and bases and how they dissolve in solution. And all the acids and bases are listed on a scale, so we can measure the acidity of different solutions. So it's measured on the pH scale, and it's lowercase p, capital H, A. And what it means is it's the potential of hydrogen. So remember we said that if there's a hydrogen ion, the substance is an acid. So what it's measuring is how acidic something is. Now, earlier in the unit when we talked about solutions in general, we talked about solutions that were concentrated and solutions that were diluted. And that just really meant how much of the stuff was dissolved in it. So the first example we looked at were those glasses of mixture where it had like a light purple color and then it went to a really dark purple color. And that was the concentration, just how much was mixed in there. And with acids and bases, we have the same kind of thing. We can mix a lot in or we can mix a little bit in. And this is different than the strength of an acid or base. So we're going to kind of take a look at how that is. So concentration is a large amount of a substance dissolved, like strong Kool-Aid. And dilute is a small amount of a substance being dissolved, like weak tea, or the stuff that was pretty clear. It was just a light pink. So it went from the light pink to the dark pink. So it's kind of like a shade of blue. This is different than the strength of an acid or a base. We can have a really concentrated weak acid, or we can have a really diluted weak acid, or we can have a diluted strong acid, or a diluted weak acid. And what determines the strength of an acid or the base is it depends on how completely the acid or base breaks into ions when it dissolves. So I put this picture up here and I wanted just to look, and it says this is 100% apple juice and it's made from frozen concentrate. So this is really concentrated apple juice. So they call the water out of it, and pretty much all that's left is the flavor in the juice. And it says here frozen concentrate. But we see that up here on the pH scale, apples are a weak acid, okay? No matter how concentrated this is, the apple juice is still a weak acid, okay? Even though there's a lot of it in here, okay? So as I was just saying, the strength of an acid or base depends on how completely the acid or base ionizes or breaks into ions when dissolved in water. Strong acids or bases are strong even if they're diluted, and weak acids or bases are weak even if they're concentrated. So here's this little diagram, and it's kind of a good picture because it shows the difference between a weak acid or base in solution and a strong one. So this hydrochloric acid is a very strong acid, and it says the strength of an acid or base depends on how completely it breaks into ions. All the ions are separated in this HCl over here, this hydrochloric acid. So it's always a strong acid. HCl is a strong acid, completely broken into ions. Now, if we took this and dumped it into a much larger container of water and diluted it, it would still be a strong acid because it's completely broken into ions. This acetic acid, which I told you is like in pickles, okay, is a weak acid because some of the particles have not broken into ions. So you can see this one's still connected. This one has ionized. It's broken into the ions. This one hasn't. This one has. So acetic acid is a weak acid. It is not completely broken into ions. Now, if we boiled off part of the water and made it more concentrated, it would still be a weak acid. Now, the pH scale measures the presence of hydrogen, or the potential for hydrogen. It ranges from 0 to 14. Right in the middle, it's 7. Okay, it means that the substance is neutral, which is pure water. Pure water is the neutral substance. Okay, it doesn't have anything dissolved in it, so nothing is broken into ions. If the pH is less than 7, okay, and it's going down towards where it's dark red, that means the substance is acidic. The farther we get from neutral in the middle, Okay, the farther from 7, the stronger the acid or base. The more completely it's broken into ions and it's separated into the hydrogen ions when it dissolved. And the closer to 7, the weaker the acid and the less it's ionized. Okay, now going the other way, up from 7, okay, greater than 7 means the substance is basic. The farther you get from 7 and the closer you get to 14, the stronger the base and the more completely that substance ionizes. Remember, that's different than concentration. Okay, you could have a really concentrated weak base, or you can have a really concentrated strong base. I mean, the concentration is just how much of it we dissolve. The strength depends on how completely it ionizes. And then again, the closer we get to 7, the weaker the base, and the less it breaks into ions, like on that little diagram that I just showed you. Okay. We use indicators like litmus paper are used to test pH. There's also something called a pH meter, and a lot of people use it in their soil to test the acidity of their soil when they're growing plants, and then adjust so that it's optimal conditions for the plants. Okay, so here's the pH scale, and as we said, 7 is the middle. It's a neutral substance like water. The farther we get from 7 going down towards 0, the stronger the acid. So the hydrochloric acid completely, like in that picture we looked at, completely ionizes. It completely breaks into ions. It's a very strong acid. So even if we only had 1 drop of it in 10 gallons, okay, it would be diluted, but it would still be a strong acid. Now, hydrochloric acid is also what's in your stomach, and it helps digest food. Okay, it's a strong acid, but it's diluted in your stomach. If it wasn't diluted and it was concentrated, then it would, it would be concentrated enough and strong enough that it would eat through the bottom of your stomach. Okay, and we said something like milk with lactic acid is a weak acid. So even if you buy milk concentrate, okay, and it's really concentrated, it is still a weak acid. Okay, and then the same thing with bases. The farther we get from 7 and the closer up to 14, the stronger and more corrosive these bases are. So something like a drain cleaner completely ionizes, it's very corrosive. Okay, and then something like baking soda, which is a base, okay, it's a weak base, and no matter how concentrated it is, it's going to be a weak base. So what's the difference between a concentrated and dilute solution? Concentrated solution has a lot of dissolved material. The dilute is only a small amount of dissolved stuff. What determines the strength of an acid or base? How completely it breaks into ions. Strength of an acid or base depends on how completely it breaks into ions. A strong acid or base can be diluted or concentrated, depending on how much of it we dissolve. The strength depends on how completely it breaks into ions. Okay. Hydrochloric acid down here is a very strong acid. Hydrochloric acid is in your stomach, it's a strong acid, but in your stomach it's dilute. Okay. They also use it to clean steel, and then it's more concentrated. Okay. Now I want you to pause the video here and make yourself a pH scale. After you got that done, hit play and we'll go over it. Welcome back. Okay. And so I put this color chart up here just to kind of make our pH scale a little bit fancier. You didn't have to do that. But it goes from red on one end to very basic on the other end where it's blue. Acids are red, bases are blue. Okay. Right in the middle is 7. So it says pH of water is 7. Down at this end, it's 0. Up at the other end, it's 14. So it goes from 0 to 14. And it says let's put lemonade on there. Lemonade is 3, so it's down here in between 0 and 7. And hydrochloric acid has a pH of 0, so it's down at the farthest end. It's the strongest acid. Okay. Soap has a pH of 10, so it's up here on this side. Ammonia has a pH of 12. It's closer to 14. It's a stronger base. Drain cleaner. Water has a pH of 7. It's right in the middle. It's neutral. It's neither acidic or basic. And then finally, drain cleaner with pH of 14 is the strongest base. It completely ionizes when it dissolves. And what happens if you mix them together? It's called neutralization. Okay, it's nothing exciting. It neutralizes. It becomes less acidic or less basic. Okay, so it's called a neutralization reaction. It's a reaction between an acid and a base. Okay, water and some kind of salt is always produced, and it brings the new substance closer to 7. So over here, we have a base, which is the sodium hydroxide. This is drain cleaner. And we have this, so this is the strongest base, and we have the strongest acid, which is hydrochloric acid. Okay, and when we mix them, it's going to make the substance closer to 7. This is a double replacement reaction. Okay, so the OH is going to go over here and take the place of the Cl. When it does that, we have this H plus this H. We have two H's. So we have H2, and we have this O. So we have this compound H2O. And then the chlorine is going to go over here and take the place of the OH. And when we do that, we have NaCl, or regular table salt. So salt is an ionic compound produced from neutralization. Okay, it takes the positive ions of the base, which was Na, combined with the negative ions of the acid, which is the Cl, okay, and make the salt NaCl. This is an ionic bond. Okay, I want you guys to answer these questions on your own. Pause the video, and then we'll go over them. A neutralization reaction is a reaction between an acid and a base that brings a solution closer to pH 7 or neutral. The two things that are produced during neutralization are salt and water. So it's really nothing exciting. So this is what happens if you have too much acid in your stomach. Okay? You have acid reflux or something, you have indigestion. You eat a base, like an antacid, and you just end up with a little salt and water in your tummy, and you feel better. Okay? And salt is an ionic compound between a metal from the base and a non-metal from the acid. And that was the end of our unit. I hope you're having a great day. Our next unit is the last unit on chemistry. It's on carbon and organic compounds. I hope you're having a great day, and we'll see you next time.